Alright, so here we are for section 5.2. We'll start it, but we'll cover it probably in the next class. We'll finish the section. But make sure every section here for chapter 5, we need to understand the previous sections to solve the equations or verify the identities or problems here. So we'll be still looking at verifying identities and working with some formulas. So this chapter will give you some formulas for difference like this. Here, for an example, the cosine of the difference of two angles. Now for an example, when you have a cosine and you are taking the cosine of difference of two angles, you can write that as you see in the right side. So the cosine of difference of two angles is equal to the cosine of the first angle times cosine of the second angle plus sine of the first angle times sine of the second angle. Now just take it as a formula. Okay. So I can go by those explanations, but what I believe is at this point we just want to see how that formula can be applied and see how that formula can be applied to get your expected result in some cases. So let's look at an example here. So here find the exact value of cos 100 times cos 55, sin 100 times sin 55. Now look at this one. We know that we can find it using the calculator because sin 100 degree, cosine 55 degree, all those things we can find it from the calculator. But we can also get it from the formula we have. Remember the formula. Let me write the formula here. Formula can be used. Let's write the formula first. Because
the cosine alpha minus beta. Remember, the alpha betas are nothing but two angles. To cosine alpha times cosine beta, the plus sine alpha times sine beta. Okay. My alpha sometimes looks like infinity. So let's write the expression here, the trigonometric expression, which is cosine 100 degree times cosine 55 degrees plus sine 100 degrees times sine 55 degrees. Now if you look at carefully, you see the right side is completely comparable to what we have right now. Do you see it? You can exactly compare it here. So what is alpha here then? If you compare it just like, so the alpha can be 100 degree, and what is beta here? 55. Now it's, so you know it. So the alpha is 100, so you can write it in terms of the formula, left side of the formula. So you can write it just like this. 100 cosine of 100 minus 55, which is cosine of 45 degree. And you know the cosine of 45 degree is 1 over square root 2, which is, you can get it from calculator. Any question here? So, we are just trying to show you that how you can apply the formulas to solve some trigonometric expression here. Now, can we verify this one? Again, at this point, just here, think the pi as alpha and theta as your beta. If that is the case, and just write the formula and see whether you can find the negative cosine theta on the right side. So
again, just assume that the alpha is your pi and theta is your beta in the original formula. And let's see what we can get. So, okay, so cosine pi minus theta. So I'm just applying the formula right now. So alpha is my pi and theta is my beta here in the formula. So I'm just writing all of those, sine pi times sine theta. Now, remember the pi is 180 degree. Do you remember what was the value of cosine in 180? You can always find it from the calculator, but just to see whether you remember. It was -1, right? So this is -1. So let's write -1 here. Keep the cosine theta as it is, because you cannot do it the cosine theta at this point. And how about the sine pi? Sine 180 is 0. Okay. So that is 0 times, I just applied the value of sine pi's and cosine pi here. Now this becomes negative cosine theta, and this part becomes 0, right? So 0 times sine theta is 0. So it's simple to verify that identity, that cosine pi minus theta equals to negative theta. Any question here? Now we have the complete list. Now remember, during the test, you will have access to all of these formulas. Even if you don't have it, just let me know, I'll give you all the formulas. But I'll not tell you what formula to use when, but I'll give you the formulas for the whole chapter. So you will have access to all of this. That means you don't have to memorize this, but over the time, when you practice a lot, you will automatically memorize it instead of going through raw memorization. Okay. Now we expand our, we explored all the formulas here. All the formulas are like sum or difference of two angles. You see, we are taking the sine and cosine difference of two angles. So all the formulas, you have alphas and betas because they are formulas in terms of sine, cosine in the right side as well.
So far we only tried the formula number 2. Okay. So far we tried only the formula number 2, but these are all the formulas for all of the sine and cosines.
Now, for the remaining part of the discussion, let's see whether we can, let's write the formulas here so that we can apply the formulas anytime we need. So you can also write it just to make sure wherever we need it, we can apply it. Now here, let's see we can find the value of sine 75 given that sine 75 equals to 45 plus 30. Now the interesting thing is here. Now if you have one angle, any angle, you can write it in terms of two other angles added or subtracted, right? For an example, let's say 75 can be written as 45 plus 30. That's one option. Or you can write 120 minus 45. You see what I'm saying? That is still 75. So any angle can be written as addition of other two angles or subtraction of other two angles. For an example, 75 here can be written as what? 45 plus 30, or 120 minus 45. Now, whenever you have those two angles added or subtracted, you can apply any of these formulas to get the answer. Because whenever you have two angles added or two angles subtracted, you can choose either one to get your answer. Now the question is asking the find sine 45. Given that 75 equals to, so now whenever the question is asking sine, so we'll be choosing either this one or this one. So we have two formulas for sine, right? We'll be choosing either of those. Since this is mentioned here that 75 means 45 plus 30, we can use sine alpha plus beta for sure. That's exactly what we need to do here. But even if that was not mentioned, let's say you know that there's sine 45, but you don't know exactly whether you are adding or subtracting. So you can either choose this one, 75 equals to 45 plus 30, and you apply the formula sine alpha plus beta, or you can choose 120 minus 45 and choose the other formula, alpha minus beta. In that case, the alpha will be 120, beta will be 45. So it doesn't matter which one you apply, your answer will be exactly always same. Now here, since it's mentioned is addition, let's apply it and see what you get. So apply the formula and see what you get. Let me give you one minute and see whether we can come up with the answer, because it's just like we will be applying this to the formula directly. Okay, so we have the answer for sine 45 using the formula. Now again, this is here right now we have sine 15 degree in terms of, we can define 15 in terms of 45 minus 30. So even if you don't like it, you can do it like 60 minus 45. That will also work. You know what I'm saying? So as long as you define anything in terms of two other angles added or subtracted, you should be okay. So for an example here, 15 can be written as 60 degree minus 45 degree instead of 45 minus 30. Right? You have a question? Yeah. Okay. So here we have another example. Suppose that cos theta equals to negative 3/5 for quadrant 2 angle theta. All sine and cosec are positive. Remember, second quadrant, sine and cosec are positive. So that's why
you see that cosine is negative. That's what it should be. And cos beta equals to 12/13 for quadrant 1 angle beta. Now find the exact value of each of the following. That might be an interesting question, that can we find the exact value of sine theta from these two, from the information we are given? Can we find the exact value of sine beta from this information? And can we find some other here as well? But now from here, let's see whether we can find sine theta first. How do you know the sine theta given the cos theta? Think about the identities you had in the previous section. You are given cosine theta, which is negative 3/5, and now you are looking for sine theta. Now first of all, you know that sine square theta equals to 1 minus cosine square theta from the previous section, right? I said that we need all the concepts in every section
We know we need the concepts from the previous sections for sure. Now here, so sine theta is square root of 1 minus cos square theta, right? Yeah, just from the previous identities. And we apply the cosine here, which is negative 3 over 5 whole square. And the rest is just algebra. 1 minus 9 over 25, and you will end up with 4 over 5. One of the things that might be a little bit important to you is, you know, since you are doing the square root, you know that you might have plus and minus, right? But at the same time, think about the quadrant. Which quadrant we are talking about? Theta is a cos theta for a quadrant 2 angle theta, right? Since that is quadrant 2, see, we need that information as well. Since that is quadrant 2, what is that quadrant? What is positive in that quadrant? Sine is positive, right? All sine. So we took the positive value. Do you see what I'm saying? So it's important to know about the information about the quadrant. Because if this is something else, let's say quadrant 3 or quadrant 4, where sine are negative, we'll probably choose the negative value. That's also important. Now, so we got our sine theta, which is 4 over 5. Any question here? The math was simple, but you know, you also need to know the quadrant information. Now, how about sine beta? Again, we can apply the same formula because we know the cosine beta, right? We can apply the same technique here. So for the sine beta, we write 1 minus cos square beta, so which is 1 minus square root of 1 minus cos square beta. So cos square beta is 12 over 13 whole square. That's in first quadrant. So we don't worry about the negative sign because all trigonometric functions are positive in the first quadrant. How much you get from here? 13 square over 12 square, which is 1 minus 144 over 169, right? How much you get? This will be is this 5 over 13? That's 5 over 13, right? And we took the positive value. So the sine beta is 5 over 13. Now at this point, you know all the four, I think you know the cosine theta, cosine beta, sine theta, sine beta, right? So you know all of these four, which are enough to calculate C and D. You see that? Because when you are doing C, you will have to apply for C. You will have to apply our formula number, and beta is beta.
And rest is simple because you already know all of these. I'm saying you know all of those four, theta and beta, right? So the rest is simple. And for the D as well, you know the formula you are going to use is the first one. And you know all of those. So this is a good example of how you can apply the trigonometric identities and the quadrant information we have learned in the previous sections and apply it here to get the other angles, and then once we have all those angles, we can apply it to the formula we have here for the sine or cosine of difference of sum or sum of two angles. Do you think we can apply C and D? We can just do C and D easily here.
just from this information? Because now we have everything that we need to calculate C and D. Any question? So we probably will stop here, but before we stop, I want to make sure that we can do C and D. Okay. Now let's try C and D and get the answer. And from next week, Monday, we'll again resume from here. But you can see that we'll also have some formula for similar formula like addition, or I'm saying sum or difference of two angles for tangent in the remaining part of this section. Okay.